Alright, starting lesson 4.5a, graphs of sine and cosine functions. Now, these types of functions, their graphs, can be found in many real-world applications, as you'll see in the future. But let's get down to the basics of it. Alright, so the graph of a sine function is an oscillation. Alright, oscillation, you could also describe that as a wave, known as a sine curve. Alright, so here's the parent function, just regular sine of x. Alright, now what's going on with this function? Alright, first thing to understand is that there's 5 key graphing points. When you're graphing your functions, you're going to want to establish 5 key graphing points. Alright, for the sine function there are 3 intercepts. Alright, there's 1, there's 2, there's 3. Alright, there's one maximum within the cycle. Alright, here's our maximum. And there's one minimum within the cycle. Okay, now this is one cycle for the graph of sine, also known as the period. So period and cycle are the same thing. All right, and a normal period for sine is 2 pi. So that's where we end, right here at 2 pi. All right, and then you'll notice that the whole thing repeats once again, and you could go backwards and repeat the same pattern. All right, so it just repeats over and over again to infinity, going both to the left and to the right. All right, now one cycle for a sine function is divided into 4 parts. All right, as stated before, a normal cycle has a length of 2 pi. So if you want to figure out what each part consists of, you just take the length of the cycle and you divide it by 4. And that gives you the increments that you're moving by. All right, so here I start off at 0, and then here I have pi over 2. Here I have 2 pi over 2. Here I have 3 pi over 2. And here I have 4 pi over 2. All right, so you just need to establish those 5 key graphing points. And you do that by understanding all this information. And it becomes really easy to graph these, what initially look like complicated functions. All right, but it's actually quite easy once you understand what's going on. All right, so here's the general equation of sine. All right, seems like there's a lot going on there, but when you break it down, it's actually pretty simple. All right, first thing we need to understand is the amplitude. All right, is half the distance between the maximum and the minimum. All right, that's your A value here. All right, and now why do we take the absolute value? Because distance is always positive, so we just take the absolute value. All right, so now we have this distance going from what's between the minimum and the maximum. All right, so this distance here, in this particular case, is 1, because since there's no number there, we have 1, all right, next to the sign. So its amplitude is 1. All right. And we take the absolute value because distance is always positive. And if the absolute value of A is greater than 1, you're going to vertically stretch the graph. It's going to get stretched out. And if it's less than 1, it's going to shrink it. And you'll get this effect. All right. So let's do some examples now. And for all the examples, I'm focusing in on one component to the general equation. What we have here, here, this whole thing, and here. So there's essentially 4 components, all right, for the general equation that you need to have a solid understanding of. Once you do, it becomes really easy to graph any sine function. All right, let's do an example. All right, so starting with example 1, once again emphasizing this idea of amplitude. All right, we have half the distance between the maximum and the minimum. All right, it's this value right here. All right, so what's going to happen here? Well, I have the amplitude. All right, take the absolute value of it. It's 3. This is a key piece of information here. Then the other thing that's important is dividing the graph into 4 parts. All right, so to do that, you take the period and you divide by 4. All right, Now, what's the normal period for a sine function? It's always 2 pi. So I take 2 pi, I divide it by 4, and I get pi over 2. All right? So my increments are going to be pi over 2. So here I start at 0, and then I move over pi over 2. And I know I move right here because if I move over another pi over 2, then I get 2 pi over 2, which is pi. So I should line up right here. So the spacing should be equal. Then I add another pi over 2, and I get 3 pi over 2. Add another pi over 2, and I get 4 pi over 2. Okay? Now, when I was at pi over 2, I know that that's where my maximum is going to be. So applying my amplitude, I go up to 3. And then it's going to come back down when I apply the next increment. And when I apply the next increment, it's going to go down again, this time to 3. And then it goes back up to 0. And that completes one cycle. All right, and if I want to cover the whole graph, I could simply repeat the procedure that I did initially. Just go backwards. So down 3, then go to 0, then up 3, and go back. All right, there we go. So that's amplitude. On to example 2. All right, example 2. Let's see here. The period, all right, of a sine function is one complete cycle of the graph. All right, the normal period for sine is 2 pi, as stated before. All right, so in this problem, you look at the b value. This b value here in front of the x is what determines the length of the cycle. So a normal period is always 2 pi. All right, but in this case, I'm dividing by b, which is not 1, it's 2. So now my period becomes pi. All right, that's a key piece of information. That's my period in this problem. All right, then I needed to divide the graph into 4 parts. Sorry for the messy writing. I'm trying to write nice. All right, then I have, when I'm dividing the period into 4 parts, I get pi over 4, because the period's pi. That's another key piece of information. And then what's the amplitude? Well, it's the number in front here. All right, that's my a value, so it's the absolute value of 1. All right, that's my amplitude. So all the parts that are circled are important pieces to graphing this function. So I start off at 0, all right, and then I move pi over 4. So since I have pi here, all right, I'm going to cut this into 4 pieces. That's pi over 4. And then I have 2 pi over 4, which is pi over 2. Then I have 3 pi over 4. And then I have 4 pi over 4, which is pi. All right, so at 0, I'm at 0. And at pi over 4, I go up to the maximum, which is 1, because that's my amplitude. All right, and then back to 0. Then I go down 1, and I go back to 0. So there is one complete cycle. All right, then you could just repeat the pattern, which isn't too hard to do. Pretty simple stuff once you get the hang of it. So there's our sine graph or sine wave. Let's go on to another example. So far we've covered what the amplitude does to the graph. We've covered what the period does to the graph and how to identify those components. All right, next idea is the phase shift. There's a little work involved with this piece. All right, the phase shift is the distance the graph is translated horizontally or shifted horizontally. Okay, so we're going to figure out our new starting point. So I set the bx minus c, which is right here, I set that equal to 0. All right, so in this case, bx minus c is x minus pi over 2. I set that equal to 0. All right, solve, and I get pi over 2. All right, that's my starting point. But where is this graph going to finish? Now knowing this isn't as important, but it helps you when graphing. So this is my starting value, but where do I finish? Well, what's the period for this graph? Well, the b value is 1, so it's not going to have an effect on the period. So I just add on the normal period length, which is 2 pi, and simplifying that, I get 5 pi over 2. Alrighty, so that's my start, that's my finish. If I need to divide the graph into 4 parts, I get 2 pi over 4 is equal to pi over 2. Alright, and then for the amplitude, the amplitude is just 1 because the a value is 1. Okay, so where am I going to start? Pi over 2. Where's pi over 2 on this grid? Here I have pi over 2. Alright, and then I'm adding pi over 2 each time, right? Because it's 4 parts. So I start here and I have pi over 2 plus pi over 2 is 2 pi over 2. Then I have 3 pi over 2. Then I have 4 pi over 2. And I'm actually going to have to go a little further. And I get 5 pi over 2. Right here. Okay. So now let's plot the points. So here's my starting value. And then the amplitude is 1. So at pi I go up to 1. And at 3 pi over 2 I'm at 0. And at 2 pi I'm at -1. And at 5 pi over 2 I'm back at 0. So there is one cycle. Alright, now I'm going to go backwards. Alright, that's all there is to it. So now we have the amplitude. We have amplitude, period, and then phase shift. Alright, and now for the piece. The vertical translation is the distance the graph is shifted vertically. Alright, that's just this component here. So what's happening with this graph? Alright, so just by looking at it here, you know the graph, all the key points are going to shift up 2 units. Alrighty, and nothing else is going on with the graph. Okay, so I know I divide the graph into 4 parts. The normal period is 2 pi. I divide that by 4, and I get pi over 2. Okay, so let's see. Here's pi over 2. Here's 2 pi over 2, 3 pi over 2, and 2 pi. Now, this is what you're going to do. Since the graph is shifting up 2 units, this is what I do. I graph the function as if there's no shift. So this is how I do it. The amplitude's 1. So notice that I'm not using dark circles, I'm using hollow circles. Alright, and then I apply the shift. So I take the hollow circles and I move them up 2 units. Alright, and there's my graph now. I could go backwards and repeat the same pattern. Alright, and we're done with that one. Alright, so we covered all components to graphing a sine function. Let's bring them all together now and see if we have a full understanding. Alright, so here we have the amplitude. The b value impacts the period. This whole piece here represents the phase shift, and this is your vertical translation. Okay. Now, before we graph this function, it's important to know that we want to reflect first and then shift our graph. Alright, so let's see what's going to happen with this graph. There's a negative in front. Alright, so just like with all the functions you've worked with in the past, you're going to have to reflect this function. And for the amplitude, I'll just use A to represent the amplitude. I take the absolute value of -3, which is 3. So that's an important piece of information. That's an important piece of information. Then I have the 2 here, which is going to impact the period. That's my B value. B is equal to 2. All right, so that's going to impact the period. So the period is going to be what? I take the normal period, which is 2 pi, and I divide by b, which is 2. So now the period for the graph is pi. That's an important piece of information. Now, going after the phase shift, all right, I need to get my starting point. So I take 2x plus pi over 4, set that equal to 0. All right, let's solve this. I got 2x is equal to negative pi over 4. Then I divide by 2. All right, and this is a complex fraction. I can put this over 1, multiply by 1 over 2, and I get x is equal to negative pi over 8. All right, that's an important piece of information. If I want to figure out where I finish, I take the starting point and I add the period to it. The period is pi. So from that I get 7/8 pi. That's the finishing value. All right, then I also have to divide the graph into 4 parts. So I take the period, which is pi, and I divide it by 4. That's an important piece of information. Okay, let's graph this guy. So negative pi over 8. I'm going to call this negative pi over 8. And I'm moving in increments of pi over 4. All right. So what's pi over 8 plus pi over 8? It's pi over 4. All right, so if this right here is an increment of pi over 8, then I need to combine 2 of those to get pi over 4. So this is where the next increment lies, at positive pi over 8. Then I have three pi over 8. Then I have 5 pi over 8. And then I finish at 7 pi over 8. Okay, where are my points going to go? I'm going to be doing a shift here, so I'm going to start off with hollow points. So I start off at 0. There's my starting point. And then based on the amplitude, I should go up 3. But I'm not, because there's a reflection. So you just do the opposite. Instead of starting off by going up, you're going to go down. All right. And then I work my way back up to 0. And now I go up. And then I go down. All right, because of the reflection. Now, I did the reflection. Now I shift. So now I shift everything down 1 unit. That's your vertical translation. Okay, so I'm going to go down 1 here, down 1 here, down 1 here, down 1 here, and down 1 here. All right, there we go. There is our sine function. Now there's a lot going on here initially. All right, it may seem a little overwhelming. If there's any parts to this explanation that you did not understand 100%, please make sure to ask for help. Okay, start off second semester on a good start. Don't let any questions linger. All right, make sure to fill in all the gaps so you start off strong on the first chapter of the semester. All right, begin the assignment at the bottom of the webpage.